Hello! It's time for another exciting math video. Today's subject, comparing fractions, including positives and negatives. So, last time we compared decimals, now we're comparing fractions. So we want to see which one is bigger, which one is smaller. And remember, when it's negative, bigger means more negative, smaller means less negative. More negative means less negative means is greater than. Okay, let's take a look. So remember the basics of fractions. The numerator, the top number, tells you how many pieces there are. The denominator, the bottom number, tells you what size the pieces are. For example, 7/10 has a denominator for 10, which means that there are 10 pieces in one whole. It has 7 for the numerator, meaning we care about 7 of those pieces. Here's a drawing. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, and 7 of them are what we care about. 7 out of 10. 7/10. 7 is the numerator, 10 is the denominator. Easy. So now we want to compare two fractions. Remember, we cannot just compare the numerators. Here's an example of why that doesn't work. We might think that 7/10 is greater than 4/5, since 7 is more than 4, but we would be wrong. Take a look at this picture. So, here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7/10, 1, 2, 3, 4, 5, 4/5. 4/5 is bigger than 7/10. You can clearly see it. 7/10 only goes up to here, 4/5 goes up to here. 4/5 is bigger. So what we need to do is change it to a common denominator. When denominators of two fractions are 5 and 10, we need the least common multiple of 5 and 10. Hence it is 10, since 5 is a factor of 10. So 4/5 becomes 8/10. So what happens is 5 times 2, 4 times 2. Now, how does that work? Many teachers teach it that as long as you do one thing to one thing and the same thing to the other, you get a fraction that's equal. And that's true, but why does it work? Well, I'm going to take 4/5, and I'm going to multiply the 4 times 2 and the 5 times 2, and that's equal to 8/10. But take a look at the number that we multiplied by. 2 halves. 2 halves equals 1. So really all we're doing is 4/5 times 1 equals 8/10. What happens when you multiply by 1? Nothing happens when you multiply by 1. It has the same value. So as long as we use the same number for the numerator and the denominator, we have a number that's equal to 1. And as long as we have a number that's equal to 1, when we multiply it, we keep the same value. So we're going to do 4/5 times 2 over 2, which is 4/5 times 1. 4 times 2 is 8. 5 times 2 is 10. That means 8/10 is the same as 4/5. Now it will be easy to compare them. Which is bigger? So which is bigger? Let me make a little bit of space. We have 7/10 and we have 8/10. Well, tenths and tenths are the same number. So now we can just compare the numerators. 7 is less than 10, so 7/10 is less than 8/10. Therefore, 7/10 is less than 4/5, since 8/10 and 4/5 are the same value. Okay, let's try a few more. Okay, so let's say we had 6 25ths and 7 30ths. Okay, we need a common denominator between 25 and 30. Here's what I do. I take the bigger number 30 and I'll multiply it by 1. 30 times 1 is 30. 25 doesn't work for 30. 30 times 2 is 60. 25 doesn't work with 60. 30 times 3 is 90. 25 doesn't work with 90. 30 times 4 is 120. 25 doesn't work with 120. 30 times 5 is 150. 25 does work with 150, so I will use 150 as my least common multiple common denominator. Remember, we have to multiply 6/25 by something that's equal to 1. So whatever is the numerator we multiply by has to be the denominator also. Since this is times 6, this will also have to be times 6 because 6 over 6 is equal to 1. 6 times 6 is 36. This is times 5, and so this will have to be times 5 also. 7 times 5 is 35. 36 is bigger than 35, so 36 is greater than 35. 36 1/50 is greater than 35 1/50, so therefore 6/25 is greater than 7/30. Let's try another one. Let's try, 8/9, and we're going to compare it with, 13/27. Yep, that'll work. All right, what's our common denominator? Well, 27 is the bigger one. 9 goes into 27, so we'll use 27 as our common denominator. This is times 1, so we need to do this times 1. That's 13. This is times 3, so we have to do this times 3. 8 times 3 is 24. Oops, I miswrote that. Let me try that again. Make it a little cleaner. Well, we know 24/27 is greater than 13/27, so this is greater than, and this is greater than. All right. Now let's try some that are negative. Remember, it works exactly the same, but everything's in the reverse order, so the bigger one will be less. So let's try negative 4, let's see, ninths, and negative 10/21. Okay, what's our common denominator? I'm going to find it slightly differently. 9 is 3 times 3. 21 is 3 times 7. So we'll do 7 times 9 is 63. And this will be 63. Now look, I did 3 times 21. So I know this is times 3. And then I mean 10 times 3 also. 10 times 3 is 30. And I did 7 times 9. So this is times 7, and 4 times 7 is 28. So 28 is less than 30, so if it was positive, it would be as less than, but it's not positive. So therefore, this should be is greater than, because negative 28 is closer to 0 than negative 30. That's a good one. We better do another one, though, for practice. So let's say we'll compare 9/10 with 23/25. Okay, so 10 is 2 times 5. 25 is 5 times 5. That means we'll multiply this one by 2, because that was the uncommon number. And we'll multiply this one by 5, because that's the uncommon number. So this is 50. This is 50. 23 times 2 is 46. 9 times 5 is 45. This would be is less than, but we're going to make this negative, and this negative, and this negative, and this negative. Therefore, since 45 is less negative than negative 46, this is greater than, and this is greater than. Okay? Now, unfortunately, we have to try some mixed numbers. I say unfortunately because mixed numbers stink. They're a pain to deal with, and they're just annoying overall. But you have to run into mixed numbers sometimes, and if you run into them, it means you have to compare them. So let's try 3 and 7/8 compared with 5 and 2/5. Well, I could do a common denominator and all of that, but I don't need to, because 3 is less than 5, and remember how as soon as you hit something that is different, you're done comparing. That's is less than. Done. Hey, these mixed numbers are easy. Yeah, if the whole numbers are different, what if the whole numbers are the same? Then you have to do what's hard, which is compare the fractions. So let's try 6 and 9/14 and 6. Notice 6 is the same as 6. And 27ths. Not 27ths, that would be crazy. I don't want to do anything still silly about this. 20 and 28. Then I don't want to use 20. I'll use 23. Okay. Now, what's our common denominator? Well, it'll be 28 because 14 times 2 is 28. So we'll do 6 is 6, 6 is 6. I'm going to do this is 28 and this is 28. This is times 1, so this will be times 1. This is times 2, so this will be times 2. That will be 18. 18 is less than 23, so this is less than, so this is less than. And reverse, reverse. Let's pretend that they were negative to start with. Negative, 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 negative. That would mean that since this is less than, now it would be is greater than, and this would be is greater than. Okay, try it out yourself. Let's see how it goes. Bye.